I wrote a comment on a lot of your homeworks, so I wanted to talk about question 27, and then you can use that new understanding to fix your question 30. And then I also wanted to talk about the two most missed questions, the two most, I can't do it, the two most missed questions on the quizzes. That is a total tongue twister, try to say it. Anyway, going back to this question, first thing I wanted to address is getting both Z1 and Z2 into this trig or polar form. If you notice on both of these, I found the R value and I found the angle. One of the questions I was asked about through messaging is, do we have to find the angle in radians or degrees? And actually, it doesn't matter. If the directions tell you a certain way, of course, do it that way. But if you're not told, you actually could do either way. Just make sure you're consistent. One person I spoke with did the first part of this in, I think, degrees, and then the second part in radians. That's an issue. Now, if you are able to get these both into this trig form, from there, I wanted you guys to start off by using the formulas. So if we wanted to do the product, so let's go over here, and I'm going to write this really nicely. Product. Using the formulas, we would multiply the R1 value and the R2 value together. So you would get root 26 in the front. So I'm going to say Z1 times Z2 equals root 26, kiss. And then we would have to add these two angles together. This is your theta 1 and your theta 2. Now, by the way, I left this as negative 0.588 because that is the correct angle that we're looking at here. You could also add 2 pi to it. It's the same thing. But since I know I'm going to be converting using these formulas and doing different work, it doesn't matter if I find what's coterminal or just use that answer. So just kind of a little FYI on that. So if I open up my calculator, what I can do then is I can take these two angles and add them. So actually, I think the last answer I had in here was the tangent inverse. I'd found this before I started recording, and I want to add to this that pi over 4. So second pi divided by 4. And I'm going to get this answer, whoa, wrong way, of 0.197. Now, I said to a lot of you guys in your homework, more than half of you, to make sure that from here we find the decimal approximation for this, because the whole point is when we multiply the original complex numbers together, we want to confirm that they're the same answer. So if I were in my calculator to take the square root of 26 and I multiply it by the cosine of this answer, I should get, wow, ooh, who would have thought, 5. And then when I do this again, square root 26 times the sine, and now be careful, not that answer, this answer right here, I get approximately 1. So I'm getting 5 plus 1i, or 5 plus I. So again, you want to rewrite this in standard form by taking root 26 and multiply it by the cosine of that angle, and then the I sine of that angle. And again, we're doing this so then we can check this with what we actually get when we multiply these together. So let's do that. So when I actually multiply these together using the complex numbers that were given, I have 3 minus 2i, and then I have the 1 plus I. Notice that I will get the 3, and then I'll get the 3i, then I'll get the negative 2i, and then I'll get the negative 2i squared. Well, this becomes I in the middle. Not me. I know. And then when we replace the I squared with a negative 1, we end up getting 5 plus I. The whole point of this problem, and I think some of you guys missed what it was asking for, is to confirm that these two are the same. And that's what you see when you actually write this in standard form. Now, this also applies to the quotient. If you understand how to do this, you can obviously fast forward the video, but I want to do this just for those of you that were struggling with the quotient idea. So going to the quotient now, when we find z1 divided by z2 using the trig form values in the formula, we're going to get root 13 divided by root 2, which is really the same thing as the square root of 13 divided by 2. Kiss, and then you can subtract those two angles now. So I can take this negative 0.588, and then I can subtract the pi divided by 4, and then I'm getting approximately negative 1.373. Now, again, the whole point is to actually find what this is in standard form. So what I could do is I could take the square root of 13 divided by 2, and then I can multiply that by the cosine of that angle. Let's try that again. I don't know why I got an accent there when I did that. Here we go. And we're getting approximately 0.501 plus, and then do that same thing again. I think I know I got the accent. My kids have been watching these yoga adventure videos. I don't know if you've seen it, but this woman has sit on your bottom. Okay, I'm not trying to be funny, but I would suggest Googling yoga adventure and watch some of these videos because they are highly entertaining. It's minus 2.5i. So there we are with the quotient. And again, that was what I really wanted to see, is that you guys got to this answer here. And now let's actually divide the two complex numbers together. So we have this 3 minus 2i divided by the 1 plus I, and we can now multiply by the conjugate of the denominator. Now, the whole point of multiplying by the conjugate in the denominator is to see that we'll get that first product, the middle terms cancel out, and then we get minus I squared, which, remember, I squared is a negative 1, so we get a 2 down here. And then on the top, we're going to see the 3. We're going to get a minus 3i, a minus 2i, and then a plus 2i squared. So for the real part of this, since I squared is negative 1, we're going to get 3 minus 2, or 1, minus 5i. And again, the whole point is to check that these are the same. Well, if you divide, you're going to see, just because of rounding, we get approximately this, or we get the exact value of 0.5, which is close to that approximation there, minus 2.5i. So that's what that note meant that I wrote to a lot of you guys. It's just really justifying that you're getting the same answer, whether you use that formula that I showed you, or you're actually using the complex numbers that were given. So just kind of a cool exploration there. So if you didn't fix or finish 30 the way that I had asked, just take the answers that a lot of you got and just confirm that you do get the same thing using both the formula and the complex numbers. Now, going on to the quizzes questions, I was actually shocked by the fact that in both classes, this was the most missed question. Not sure what that means for the average time taken. I think that's a typo. I don't know. But anyway, so I'm thinking it's like 0.5, 5.7, and I think they're saying times 10 to the, no, that couldn't be right, 570 seconds. I don't know. Anyway, yeah, again, shocked by this one. They wanted you to find the quotient on this one. So just as we did, you're going to divide the front two numbers, so the 7 divided by 2, and get the 3.5. And then remember, with the angles, I'm going to write this as KISS. I'll go this way. KISS. I'm going to subtract those angles, and I'm going to get pi. Now, when you rewrite this, cosine pi plus I sine pi, remember that your cosine is negative 1, your sine is 0. So the correct answer for this should have been negative 3.5. I think the most guessed question, or the most guessed answer that was wrong, was this one. So I'm not sure why that happened. If you messed up the ordered pair for the cosine, of pi, sine pi. I'm not sure if it was something like that or just forgetting that when you multiply by 0, this whole term goes away. Not really sure, but that was in both classes the most missed question. Also in both classes, this was the second most missed question. It said to convert this to this rectangular ordered pair to polar. Obviously, we're not so much concerned about the r value here because all of these have the r value. It's more about the angle. Well, keep in mind that this is a negative x and a negative y, so we're talking about this third quadrant. So right away, you can get rid of any angles that are not in the third quadrant. And honestly, I think it was one of these two that was the most guessed outside of the right answer. So right away, recognizing what quadrant you should be in. Now from there, I want to find what that angle is. So remember, I can do the tangent of theta equaling the negative root 2 over the negative root 6. The two negatives are going to cancel, but you're going to get the square root of 2 over 6, which is the same thing as the square root of 1/3, which is the same thing as the square root of the numerator, which is 1, over the square root of the denominator. Now, sure, you can rationalize this, but personally, I think it's easier to think, where do we divide y by x and get this quantity? Well, remember, we want to flip the root 3 over 2, so that means it would have to be our x value. We'd want to do it this way. So then when we flip that second fraction, we'll get that answer. So we're really looking for a large value of x followed by a small value of y. But again, they both have to be negative because we're in that third quadrant. So long x, short y, we're looking at this 7 pi over 6 as your answer. So just be careful with that one. Let me know if you have any questions, but that is what I saw in the quizzes and then obviously the homework.